It's Math 1, Unit 2 review. Number 1, it says tell whether the function shown is a linear or nonlinear. So what I have to do is look at the changes in the y. So I go from here to here, I increase by 2.5, and I go from here to here. Well, you say, okay, well, half will get me to 10, so that's going to be also 2.5, and then from here to here is a 2.5, so the answer is yes, or it's linear. Okay. So if I increase by the same x and the same y every time, then that is a linear relationship. And so how would I express the relationship between this table here? Well, the first thing I want to do here is I look at the data and say, okay, it increases. So let's see, does it increase by 25 the same amount every time? And it does, right? It's always increasing by 25. So how I set this up is it's always y is my output, and it's going to be the change in y is 25 times the input, right? And so if I look at this, it's going to be b. Okay, it always has that same the change times the input equals the output. Number 3, Bill earns $24 per hour using P for pay and H for hours he works. Write a function rule that represents the situation. So what we're going to do is I'm going to kind of do this by setting up a table. So the input is hours, and the output is pay. So if he works 1 hour, he makes 24. He works 2, he works 48. He works 3, he works 62. Right? And so if you look at this, you're looking at an increase of 24 every time. Okay? So it's just like the question we did above. So we're looking at, okay, so y, or what we call y, or the output is my p, equals the change, which is 24, times the input, which is h. Okay. Number 4 here says find the 4th, 7th, 10th terms for the sequence. Okay. So I have an explicit formula here, so I got to go ahead and find a of 4, which is my 4th term. Okay, so that's 7 plus 4 minus 3 times 3. Okay. So that equals 7 plus 1 times 3, and 7 plus 3, and that equals 10. Okay, that's my 4th term. My 7th term is a of 7. So that's 7 plus 7 minus 1 times 3. And that's 7 plus 6 times 3. And that's 7 plus 18. And that's 25. Alright, so if I can squeeze this last one in here. And the 10th term, a of 10 equals 7 plus 10 minus 1 times 3. And I'm going to scoot this over just a little bit. I'm going to say 7 plus 9 times 3 equals 7 plus 27 equals 34. Okay. Write an arithmetic sequence and represented by the explicit formula. What is the recursive formula? Okay. So I have my explicit formula right here. I want the recursive formula. All right. So the recursive formula is always a of n equals a of n minus 1 plus the common difference. Okay. The explicit formula is a of n equals a of 1, which is the first term, plus n minus 1 times the common difference. So with that being said, the common difference is right there, so the answer is a of n, and this is all I need to plug in is the common difference, negative 4, right? So you could also see it written as a of n just minus 4. So we want to tell whether this is an arithmetic sequence. Okay, if it is, write the recursive and the explicit formula. So you remember the change needs to be the same. Okay, so if I look at this, okay, that's my first, second, third, and fourth terms. So to go from here to here, I increase by 3, and from there to there, I increase by 3, and from there to there, I increase by 3. So that is arithmetic because it's the same, right? It has that same kind of linear relationship. And so I'm going to go ahead and write the recursive and arithmetic explicit formula. So the recursive is a of n equals a of n minus 1 plus the common difference. The explicit one is always a of 1. I'm sorry, I know a of 1, that's negative 5. Negative 5, it's kind of hard to see, negative 5 plus n minus 1 times the common difference. In this case, it's 3. Okay. Same one over here. Here's my sequence. And that's the first, the second, the third, and the fourth. Okay? And so I'm going to see as I go from here to here, okay, a little trickier to do here, but I got to go from 20 to 0 and then to negative 18. So that's negative 38, okay? And then it goes back to a positive, and then it goes back to a negative. So realizing that an arithmetic sequence can't do that. It can't go positive, negative, positive, negative. So this is not arithmetic. So we cannot do that one. Okay. Number 8 says write the range for these domains. So we basically got to figure out 3 different equations, right? We got to figure out f of negative 4 equals negative 3x plus 2. I'm sorry, that's when I plug in a 4 for the x. Okay. So just to rewrite that because it's a little bit sloppy here. So I'm going to find that one. Okay. So a negative is a positive. That equals 14. Probably going to run out of room here, but I'll just do the best I can. And then f of 2 is equal to negative 3 times 2 plus 5. So that's negative 6, that's negative 1. And then f of 5 is negative 3 times 5 plus 2. That's negative 15 plus 2, and that's negative 13. Okay. So same thing here. I just plug them in. So I'm going to start with f of negative 2 equals, now be very careful to use your parentheses here. So that's 4 minus 4, so that's 0. Find f of 0. All right, plug it in there. And that's negative 4. And then f of 3. Okay. And that equals 9 minus 4, and that equals 5. All right. These next two in this video. So it says, state whether this should be continuous or discrete data as John's height over time. Okay, that's going to be a continuous one. Okay, because there's no breaks in the data. So if say for example he's 2 feet tall when he's a little kid and he grows up to be 6 feet tall, he's going to touch everything in there, right? If you go from 2 feet to 6 feet, you have to be every height. You got to be 2 feet and an inch, 2 feet 0.1 inches, 2 feet 0.2. There's no breaks in it. Okay. Price of maple bars. Well, you could make the argument that everything's going to increase and be continuous, but most likely, the maple bars, say they're $1, and then after a while they're $2, and then maybe they're like $2.50. And so I doubt that you're going to have a situation where they're going to, before the company says, okay, if we're going to raise the price, we have to do it a penny at a time or a fraction of a penny at a time. So this is going to be discrete.